The other day I was working on my Redis library for Racket, and I wanted to improve its connection pooling implementation. And while I was doing that, I realized I had written that same code a number of times. So I have a connection pool in Redis Racket. I have one in HTTP Easy, which is an HTTP client. I have one inside of Machacha for database connections, and so on. And so I figured it would be kind of fun to try and extract that so that it can be reused into a generic connection pooling or resource pooling library. So let's get started and do that. So I'll call it Racket Resource Pool. Let's give it an info file. Or actually, this one I might actually split into two separate packages. So one is going to be Racket Resource, or just Resource Pool lib. Let's work on that first. Info.racket. So I think since it's just going to be a data structure, I'm going to put it in the data collection. Right, so there's a bunch of data structures over here. Some of them are provided by base, but some of them are provided by other packages. And I don't think there is a pool over here. So let's see. The version is going to be 0.0. The dependencies are going to be probably just base, and then the build depths are going to be empty. And let's just add since we are in the data collection, all we really have to do is add a pool.racket. Now I gotta think, do I want it to be data/pool or data/resource pool? I think I'm gonna just let it be data/pool. So it's gonna be in Racket base. And we are gonna have a struct to represent the resource pool. I think I'm gonna use the short name though. So it's gonna be pool. It's going to contain a custodian. It's going to have to know how to make new resources. So make resource, and then how to destroy them. Destroy resource. Maybe let's make those the first fields. And it's going to have a custodian, and then it's going to have an internal thread that's going to be managing these things. So maybe let's call it manager. Okay. Going to provide pool, and then we're going to provide a smart constructor to make a pool. Yeah, let's see, how do we want to... Might be a bad idea, but we'll see. Maybe it does make sense to have destroy possibly be optional. So void just does nothing given some argument. Void 42 is just does nothing, returns void, and ignores its argument. Let's require a Racket contract here, and let's see. So the make function is just going to return any single value. The destroy function is going, what I need, star for this. Destroy is going to take any value and return void. And the result of this function is just a pool. So yeah, maybe actually it doesn't even need to hold those fields now that I think about it, because the manager thread can just close over make and destroy, and maybe I'll just call these make resource now and then destroy resource. Right, so we got a pool, and then we're going to make a custodian and then parameterize the current custodian with it. I'm going to preserve it, and then make manager make resource destroy resource. Okay, and then we're going to provide make pool. All right, and then let's just stub out make manager make resource destroy resource. Oh, and I suppose we'll also need to know what the idle timeout is going to be for some of these resources. So idle TTL, and then maybe let's just default to something like an hour in milliseconds. So idle TTL is going to be an exact positive integer, or plus f.0, and then we're just going to pass that in as well. Over here, that's going to be void. Okay. And then the other operations, so we know how to make a pool. It doesn't really do anything right now. We know how to identify a pool. Next, we should add an operation for taking things out of the pool. So pool take, and then pool release, and then call with pool resource. It's probably all the operations we need to provide. Or also maybe a pool shutdown, or just close maybe. Maybe let's define a logger for resource pool. Okay, let's stub those out. Pool take is going to take a pool. Yeah, I'm going to add contract to these. NEC is void for now. Line contract, pool release, P, R, pool, NEC void. Line contract, pool close, P. And then the last one is going to be, whoops, call with pool resource. It's going to take a pool and an F. Give some value to anything and then return anything. For now, it's just going to be void. Okay. That all compiles. Yeah, that seems reasonable. Okay. And then the way our manager is going to work is it's going to spawn a background thread that's going to keep looping continuously. And it's going to keep a couple of lists of resources. So one is going to be the idle list. The second is going to be the busy list, which is, so the first one is a list of allocated resources that aren't in use. The second one is allocated resources which have been given out. So they've been taken by somebody but haven't been released yet. We're going to have a list of waiters, and this is where we're going to put, oh, and I guess the other thing I forgot is we need a pool size, or just a size. Maybe by default that can just be something like 8. Exact positive integer. Maybe we'll just also keep track of the total number of resources that are, of open resources or allocated resources, however you want to call it. So the idea with the waiters is when the pool is full and somebody tries to take a resource, we just add them to a wait list. And then when the next resource is released, we send them that value when it's ready. And so because this is running in a separate thread, what we're going to do here is we're going to sync and handle an event, and the event is going to be thread receive event, because Racket threads all have a mailbox associated with them. And so other threads in the system can send this thread messages to which it can reply and handle. And so we're going to do that. Unfortunately, the thread receive event, rather than when it's synchronized, instead of synchronizing to the value that the thread received, it actually synchronizes to itself. So we're just ignoring the argument here. A handle event is, if you haven't used these things before, handle event is kind of like a map for events. So we're taking this event, we're waiting on it, or we're producing a new event that when synchronized will map the result of this event with this function, using this function. But again, because this synchronizes to itself, it's not very useful, but it does let us know that we can thread receive here without blocking. And that's kind of what I'm interested in. So let me bring in Racket match. And let me just stub out what our messages are going to be. The first message is going to be lease, and it's going to take a channel. So this is someone trying to take something or take a resource from the pool. The second one is going to be release. It's going to take a resource. Let's just void it out. And then the final message is going to be shut down. It's also going to take a channel. Or let's call it close. Because it's going to want to reply on that channel. Okay. Maybe let's rename size here to max size. All right. And so what we're going to do here, oh, and let me also, separately from the loop, I'm going to keep a list of, or a hash of deadlines. And then have some way to reset a resource's deadline given R. So I'm going to want to hash set deadlines with R to the current in exact milliseconds plus the idle time. And then remove deadline R is going to hash remove from the deadlines R. Okay? And you'll see in a sec why this is important. Okay, so maybe let's try and implement lease. Lease is going to check if the well, actually, let's do this the other way around. So if we have any idle resources, then what we're going to do is we're going to take the first one out. Then we're going to remove its deadline. Then we're going to put it on the response channel, and then we're going to loop, and we're going to say the total is unchanged. The idle has changed, so now we're just returning the rest of the idle list. We're going to cons the resource onto the busy list, and then the waiters is going to be unchanged. Okay, so this is if we have any idle connections or idle resources. If we don't have any idle resources, but the total number of resources is less than the max size, then we can allocate a new resource. We can make a resource. We don't have to do anything with its deadline because it doesn't have a deadline because it's new. So we just channel put it onto the response channel, then loop, increase the total by 1, the idles remain unchanged, we add the resource to the busy list, and then the waiters remain unchanged. And then finally, what is it complaining about? That must be just a bug in my linter. Okay. And then finally, so if we have no idle resources and we're at full capacity, then what we do is we just loop, the total remains unchanged, the idle remains unchanged, busy remains unchanged, but we just cons the response channel onto the list of waiters. Okay? And then when a resource gets released, maybe let's also make this take a response channel, but let's put it at the end. Unless this resource, well, I'm trying to think how I want to do this. Yeah, let's actually change this to a con. So if this resource is a member of the busy list, then we'll do something. Otherwise, this means somebody tried to release a resource that we never leased to them, which is wrong. And so what we should do is just channel put on the response channel some sort of error. So maybe let's also add a struct exin fail pool as an exin fail. Maybe let's provide that exin fail pool. Yeah, so we'll just put an exception on the pool and say exin fail pool and continuation marks. Okay, and then we'll loop. Okay, but if it is a member of the busy set, then we are going to reset its deadline. And then check. If waiters is null, then we don't really have to do anything, just loop, add it to the idle set, remove it from the busy set, and then the waiters is going to be unchanged. Else we are going to get the first waiter, put the resource. I suppose we don't need to reset the deadline in this case, right? Because we're actually not putting it in the idle set anymore. So we'll just put the resource on that waiter's channel. The total remains unchanged, the idle remains unchanged, the busy remains unchanged, and then the waiters is going to be the rest of the waiter list. Now there's a problem here because when we add somebody to the waiter list, they're always added to the head of the list, which means sort of the ordering is like last in, first out, which is not great, right? Because you could have two waiters waiting on a resource, and then the oldest one might wait the longest, or might have to wait longer than the newest one, which is wrong. But we'll fix that in a sec. Okay. And then for close, what we're going to want to do is also have a con in here. If the busy list is null, then we'll just close all of the connections and quit, or all the resources. Otherwise, so say somebody calls pool close without releasing all the resources, we're going to want to send them an exception. Fail pool, and continuation marks, and then attempted to close pool without releasing all the resources. And then same thing, loop again, so total idle busy waiters. And then over here, all we're gonna do is for each of the idle list, we are going to call destroy resource. And then just let the thread end, so we're not going to loop here. But what we should do as well is just capture any exceptions and send them back on the channel, and then loop. So that if any of these individual calls to destroy resource raises an exception, we're gonna want to avoid sort of stopping halfway through, right? And let the caller deal with that. Okay, so then over here at the top, let's change this to an append. So append to the waiters a list of that channel. So now we don't have that problem anymore. This seems expensive, but it's probably fine. If it turns out to be a bad idea, we can eventually change this into something else, like maybe a vector. Okay. Cool, so we've handled the basic operations here. But then in addition to that, we're going to want to have like an idle timeout event. And this is going to be if the set of deadlines is empty, then we basically don't care about this event. This is going to be an event that never synchronizes. Otherwise, it's going to be an alarm event that's going to be the current in exact milliseconds plus the minimum deadline. So hash values, deadlines. Right, so remember the deadlines hash is a hash of values to their deadlines. Oh, and I suppose they are already milliseconds, so I don't need to add anything there. Right, so we're getting a list of all the values in the hash, which are just timestamps, and we're finding the smallest one and making an alarm out of that. So this event will synchronize at the first expiring deadline. Okay? And so in our sync here, we're handling the thread receive event, but now we're also going to want to handle the idle timeout event. And the way sync works is it'll pick the first one of these that is ready for synchronization. Okay? So either we're going to handle on a message, or we're going to handle on an idle timeout. And then when we get an idle timeout, what we're going to want to do is, for every resource whose deadline has passed, in hash deadlines, we're going to want to call let's just void for now. We're going to want to call destroy resource on the resource, and then remove its deadline, or maybe remove its deadline and then call destroy. Okay, and then if the destroy call fails, we're just going to log a resource pool warning. Failed to destroy idle resource. Oops. Okay, let's just put that all on one line. Okay. So, oh, whoops, and I also need to make sure to only do this when the deadline has passed, right? So when the deadline is before now. Okay. And I guess I also need to collect the remaining idle resources. So this is actually going to return a list of new idle resources. So we're going to fold here, new idle is going to be null. Instead of when, we're going to use a cond. So in the case when we're removing a resource, we're going to keep returning new idle. Otherwise, we're going to cons resource onto new idle. And then here we're going to loop. So the total is now going to be the sum of the length of the new idle resources and the length of the current busy resources. So new idle, busy, and then waiters. Or I mean, it could also just be subtract from the total the length of the new idle. That way we don't have to do two length calls. Maybe instead of calling it new idle, I'll just call it idle star. Okay. Then again, it might also be a good idea to keep track of how many connections we destroyed. And destroyed is going to be and destroyed 0. I have a typo here. So here actually we're going to call and destroyed, and then here we're going to add 1 to and destroyed. So that way I can just log resource pool debug here. Destroyed and idle resources. Okay, and then here we can just subtract and destroyed. Cool. Okay, so our manager is just gonna continually loop this thread forever, wait for messages, and then every now and then it's gonna reap or destroy idle resources. Seems fine. So let's look at what take would look like, what an implementation of take would look like. Probably take should also take a timeout. Exact non-negative integer or false. So this means being able to have a timeout here just lets the caller give up after a while. So let's see. To take a resource, we're going to need a channel that we're going to pass in with the least message. So let's make a channel. And then thread send to the pool manager the message lease that channel. Okay, and then we're going to want to sync timeout on the channel. Actually, this isn't going to be good enough, and maybe I'll show why in a minute. But yeah, we're going to sync on the channel, and so we're going to return either false. I mean, this is kind of redundant because NEC includes false, but I like to do this because it shows intent. Okay, so this is going to work. It just has some problems. So let's make a pool where maybe the function just sleeps for 5 seconds and then returns a value. And then if we try to take from that pool with a timeout that's less than the time it takes to serve the request, maybe just 1 second, that works just fine. Except now if we try to take from the pool without a timeout, this is going to be deadlocked. Because the problem is the manager thread, because it just calls channel put here, let's see, we would be on this branch there. So it just calls channel put here. So now, even though 5 seconds later it created the resource, it's stuck here because there's nobody there to take a value off the channel, because channels aren't asynchronous. So 2 threads have to exchange a value for a channel put or a channel get to proceed. And so here, by timing out, we've actually stopped trying to take anything off that channel, so there's nobody to take the resource off of this channel. And so our manager thread is just stuck. So instead, what we can do here is we can sync. We can either sync on the channel or sync on a handle event of an alarm event, where we take the current and exact milliseconds and add the timeout. Well, we only want to do that if we have a timeout. Otherwise, we want to do a never event here because we never time out. Okay, so when we get the alarm, we're going to want to spin up a new thread that all it does is it gets the value off of that channel, and then we're going to return false. Okay, so the result of this event is going to be the value false, but then as a side effect, we're also spinning up a new thread that just gets that value off of the channel. And I suppose it also should release it. So PNR. Actually, PN channel get. Right? And so if we time out, we know that there's going to be a thread somewhere that's going to release this resource eventually. And so this is better. Now, if I do the same thing, timeout after 1 second, I guess we haven't implemented pool release, so, but this should still work. And now if I try to get another one, it works just fine. Oh, I suppose this is milliseconds now. But yeah, that works. That all works fine. Now we're gonna, because we haven't implemented release, what's the default size? Let me just change the size to, well, actually I could do that here, right? I could say size is 3. So take, and then, oh, that's surprising. Oh, I suppose because we're timing out. Right, we never, we don't wait to be given a resource. So now we're just filling up the pool. But the thing I wanted to show wasn't this. It was what happens when we break while we're synced here. And so if I take a resource, I wait 2.5 seconds. I'm not going to wait that long. I'm just going to press Control C. And now the sync was interrupted with a break exception. So now, once again, the pool is deadlocked. Right? No matter how long I wait, it's not going to give me anything, because we have the same problem as before. Because we broke out of here, this event never synchronized, so we never spawned that thread to consume the resource and then release it. So what I'm going to do here is just add a sync function that's going to do, it's going to have the contents of this lambda. And so here we're just going to call sync. But then in addition, so another option might be to parameterize break here and turn off breaks. But but I don't like that as much because I want to be able to break sometimes. I just want it to be safe, right? So instead, I'm going to catch any break that shows up here, keep track of the exception, call sync, and then re-raise the exception. Okay? Because we do want the break to bubble up. Okay, so now if I do the same thing I did before, I'll break and then try to take again, and in 5 seconds or so we should get a value back if I did everything right. Yeah, there we go. Okay. I'm just going to abstract the message dispatch stuff over here a little bit. Well, actually, let's implement release and then we can do that. So for release, we're going to do a similar thing. Let's see what that looks like. Yeah. So we're going to make a new channel, and then we're going to send the thread a message. Whoops, pool manager P. We're going to release R, and then wait for responses on that channel. Okay. And then we're going to sync on the channel if the value is an exception. We're going to raise it. Otherwise, yeah, we're just going to return void. So this has that same problem though, right? If somebody breaks here, then the manager is never going to be able to proceed. I'm just going to keep that as is for now, and I'll just implement close. So thread send pool manager P, and then close, and then the same thing, maybe xn sync channel, when xn, maybe xn raise. Right, so now we got really similar implementations here. We have a somewhat similar implementation here, but then this one also handles breaks properly. So how about we just abstract that a little bit. So in the first case, I think I'm going to just define a syntax rule called dispatch. It's going to take a pool, it's going to take an ID of what to dispatch, and then some set of arguments. So this one is not going to do anything special. Manager. Whoops. It's just going to pass. It's just going to abstract the thread send call. So thread send, I'm just going to call dispatch now on P, release, and then the channel. Okay, that just cleans that up a little bit. And then for these other two, we're going to want to have a variant of this called dispatch block. blocking. It's going to take the pool, and it's going to take an ID, some set of arguments, but it's going to make its own channel. And then it's going to do the whole define sync thing. Where it just syncs the channel. In this case, we don't actually care about value. And it's going to call with handlers, X and break. Yeah, when we get a break, we're going to call the sync and then raise the exception. And then we're going to define the value as maybe exception syncing on the channel. Don't forget to dispatch PID arg and then the channel. When value is an exon, raise it. Otherwise, maybe just return it. Okay. And so now here we can just call dispatch blocking release R. And here we can dispatch blocking close. And we have to void out the result values because we don't care about them in these two functions. Okay. And maybe let's add some logging. So, let's see. Log resource pool debug. Adding to idle set. Sending to waiter. Okay. All right. Destroying all idle resources, and then log resource pool debug, closing resource pool manager. All right. Close pool without releasing all resources. And over here, we're going to log resource pool debug, releasing idle resource. New resource, and then log resource pool debug, adding waiter to wait list. Okay, and then we're going to implement call with pool resource in a couple minutes here. But let's see, that's what's it called? Racket log topic level. So for the resource pool topic, we're gonna want to see debug logs. And let me make sure I've loaded the code. So I'm going to make a new pool here. It's just going to return a list of current inexact milliseconds, just so it's easy to identify. Well, relatively, well, let's say current seconds instead. Okay. Let's take something out of the pool. Pool take. Okay. So we got a thing now. If we take another thing out, got R1 and R2, right? And we can see we leased new resources there. If I pool release PR2, it adds it to the idle set. Expected number of arguments. So oh, I meant to do a cons there, not a car. So let's do that whole thing again. Take R1, take R2, and then pool release. Well, let's release something that isn't in the pool, right? Like the number 1. We're going to get an error, but it looks like I also messed that up. X and fail pool. It was given 3. Oh yeah, because I forgot to format this. And then I feel like I probably made the same mistake over here. Nope, there's no message there. So going back here, R1 and R2, and then try to pool release P1. I got the argument order wrong. For some reason I always mix these up. Yeah, it's the message, then the continuation marks. X and fail. MP -1, 2, pool release P1. Right, so this was never released. That's completely fine. We release R2. I guess I also made a mistake there. Right, of course. You got to remove something from the busy list. Okay, define. Do that whole dance again. R2, pool release PR2. Oh. That's interesting. I wonder what happened. Oh, of course. So when we add something to the idle set, we never actually tell the caller that we did the thing, right? We do tell them when, oh no, we don't tell them here either. So let's see. Yeah, in this case, I'm just going to move it up here. So if we know for sure that this is a resource that can be released, at this point we can just tell, well, no, maybe we should actually only reply here. Let me just call this waiter. Yeah. Okay. We got our R1 and R2, and then pool release PR2. Okay, that works fine. Now if I try to release R2 again, it should complain, right? Because it's not been leased. If I take and redefine R2, now, yeah, instead of leasing a new resource, it just leased the idle resource that we released earlier. Okay, and then the same thing, if I release R1, that's 281, and then if I try to take something out again, R1, then that works out just fine, right? It's the same thing. And now if I want to define an R3, R3, takes a second and I get a new resource. Okay, and now the idle time for these things is very long. So maybe let's just start over and make a pool with a very short idle TTL of maybe like 5 seconds, right? And now I'm just going to drop the sleep here because we don't need it anymore. So R1 we're going to take, and that leases a new resource. And there's nothing to expire here, right? So if we wait 5 seconds, nothing's actually going to happen because we only expire things that are in the idle set, but now our idle set is empty and we have one thing in the busy set. But if we pool release PR1 and then give it 5 seconds, yep. Oh, it destroyed 0 idle resources. That's interesting. Let's give it another 5 seconds. Let's see what happens. I wonder if, is it the message that's wrong? Yes. It's what I should have done is the add one should have happened here instead of here, right? Because this is where we destroy the resource. So our count was just off. Now if I do the same thing and then release R1 and then a couple more seconds, destroyed one idle resource. Maybe just do that. Okay, and another thing I want to do here is sort of the way this works out. It could be that many resources are have almost the same idle deadline or idle timeout. So what could happen, so they're almost the same, but they're sequential, right? So maybe maybe you have 10 deadlines, each 1 millisecond apart. So what could happen is we keep making these timeout events and they immediately synchronize, and we end up releasing one of these at a time, which is not ideal, right, for performance. So instead, I'm actually gonna add like 30 seconds to every one of these. That way, if we have a sequence of deadlines that are about to hit, we'll catch many of them at a time. So maybe let's try and demonstrate this problem. Yeah, let's see. And then in a loop, just R, pool take P, yeah, actually, let's run this in a thread, and line R, pool take sleep for, I don't know, 100 milliseconds, pool release PR. Okay. And then we're going to wait on all those threads to finish. Okay, so now we have a bunch of resources. And yeah, you can see it destroyed 3 of them, but then it destroyed these ones one at a time. Okay, but if we just add a small delay over here, I'll do 5 seconds for now just because that'll be easier to wait for. Okay, and now it just destroyed them all in one go. But yeah, let's just do 30 seconds, maybe even a minute. Like, I feel like this sort of a resolution is acceptable. Maybe do that. Okay. And now obviously I should be able to take another resource out of the pool. Whoops. And yeah, that works just fine. Okay. So we have all our primitives here. Oh, I guess we never tested pool close. So for one, if I call pool close right now, because I took R1 out of the pool, I should get an exception, right? But my pool should still work. So if I pool release PR1, that works fine. And then if I try to close the pool, then that worked, except if I go back here, we never reply on success. Okay, so here I need to channel put, I'll put OK actually, because I put true here, but I don't like that. Maybe even released. And then closed. Okay. Now let's do that same thing again. Pool take P, pool release P, or yeah, let's just release it. Pool close P, and that just works, and then it's destroyed. So now if I try to take a resource, I believe I'll get an exception, right? Because the thread isn't running. And that's fine. I'm okay with that being the exception. If necessary, we can improve it later. And now for the implementation of call with pool resource, one way to implement it might be to just have a, with handlers over here, capture the exception, maybe have an entry for the resource there, and then void. Let's see, so set the resource using pool take P, and then call F with the resource. Or actually, we could have just done this, right? Call F with the resource, and then finally pool release PR, and then if there is some sort of an exception, then release PR, and then re-raise the exception. And this would be fine, except this has problems if F calls a continuation. We might never actually get to run these releases. So instead, what we should do, set this to false and use dynamic wind. So first just set the resource by taking it out of the pool. Then call F with the resource, then pool release the resource. And so this has the advantage that if F happens to jump out of here with a continuation, then the exit side, I forget what they're called, I think they're enter and exit, dynamic wind, or the pre and the post thunk. This thunk will run when F escapes through the continuation, and then if from the continuation we jump back into here, the pre-thunk will run once again. Okay, so we'll always take and release the resource properly. Okay, so we have that. I guess we would probably also want to add a timeout argument over here, which is false by default. So timeout is going to be either false or an exact positive integer. And so if the value happens, or we're going to want to call take with the timeout, and then maybe unless R, we're just going to raise an exception here. Fail pool timed out while taking resource current continuation marks. Okay, so we don't even want to run F if we're unable to get the resource in time. All right, I think that's it for today. I might do another screencast on testing this and maybe on documentation. But yeah, hopefully this was entertaining. Thanks for watching.